logarithm takes values that are orders of magnitude apart, for example 0.1, 1, 10, 100, 1000, for example, and spaces them evenly within a reasonable range. The base 10 logarithm function denoted by log 10, as you can see, or log 10, computes how many times 10 can be multiplied by itself to equal a number. Okay, for example, log 10 in base 10 equal 1 because 10 is used only once to get the result of 10. The log 100 in base 10, okay, equals 2 because 10 is multiplied twice to reach the result of 100. Computing other log 10 values is difficult, requiring the use of the calculator. Let me to explain the decibel or dB. The decibel or dB is a handy function that uses logarithms to compare one absolute measurement to another. It was originally developed to compare sound intensity levels, but it applies directly to power levels too. Okay, after each power value has been converted to the same logarithm scale, the two values can be subtracted to find the difference. The following equation is used to calculate a dB or decibel value, as you can see here, where P1 and P2 are the absolute power levels of two sources. Here, as you can see, dB equal 10 multiply log P2 subtracted from log P1, actually log P2 minus log P1. Okay, this is equal to the log P2 over P1. Okay, and as you can see here, P2 represents the source of interest, and P1 is usually called the reference value or the source of comparison. Okay, the difference between the two logarithm function can be rewritten as a single logarithm of P2 divided by P1, as you can see here. Okay, here the ratio of the two absolute power value is computed first, then the result is converted into a logarithmic scale. I will show you some examples. Oddly enough, we end up with the same two methods to compare power levels with dB, a subtraction and a division. Thanks to the logarithm, both methods arrive at identical dB value. Be aware that the ratio or division from the equation is the most commonly used in the wireless engineering world. Actually, you know that here now we don't have program because the result of subtraction and also the result of divide, or both of them are same. Alright, now let me to explain about the important decibel laws to remember. There are three cases where you can use mental math to make the power level comparison using decibel. By adding or subtracting fixed dB or decibel amounts, you can compare two power levels through multiplication or division. Okay, you should memorize the following three laws, which are based on dB change of for example 0, 3 and 10 respectively, and are known as the law of 0, law of threes and law of the tens. Okay, let me to explain each of them. All other dB cases require a calculator, so you will not be for example tested about them. Let me to explain about these three laws. First, law of 0. A value of 0 dB means that two absolute power values are equal. Okay, let me to show you. Actually, if the two power values are equal, the ratio inside the logarithm is 1, as you can see in this example. P1 equal 10, P2 equal 10, for example, watt or milliwatt. Then log of 10 over 10 in base of 10 equal to log 1 over 10, and it is equal to the for example 0. This law is intuitive. If two power levels are the same, one is 0 dB more than the other. This is the law of 0. Let me to review. A value of 0 dB means that the two absolute power values are equal. The next law is the law of threes. A value of 3 dB means that the power value of the interest is double the reference value. A value of minus 3 dB means the power value of interest is half the reference. When P2 is twice P1, the ratio is always 2. Therefore, 10 log 2 in base 10 equal to the 3 dB. When the ratio is 1 over 2, okay, the equation equal to the 10 log 1 over 2 equal to the minus 3 dB. The law of threes is not very intuitive, but it is still easy to learn. Whenever a power level doubles, it increases by 3 dB. Whenever it is cut in half, it decreases by minus 3 dB. As you can see here, for example, the absolute power of P1 is 10, absolute power of P2 is, for example, 20. Because of that 10 logarithm, 20 over 10 P2 to P1, okay, in base 10 equal to 10 log 2 over 10. The logarithm of 2 in base 10 with calculator is equal to the 0.3, and when we multiply it to 10, the result is 3. And here you can see the P1 has a 20 milliwatt or 20 watt absolute power, P2 10 milliwatt or 10 watt absolute power, and the equation equal to the minus 3. This is the law of 3. About of law of threes, we can say a value of 3 dB means that the power value of interest is double the reference value. Until now, we learned about two rules: law of 0, law of threes. About the law of 0, it means that two absolute power are equal. About the law of threes, it means that the power value of interest is double the reference value. About the law of tens, a value of 10 dB means that the power value of interest is 10 times the reference value. A value of minus 10 dB means the power value of interest is 1 over 10 of the reference. When P2 is 10 times P1, the ratio is always 10. Okay, therefore 10 log 10 equal 10 dB. When P2 is 1/10 of P1, then the ratio is 1 over 10, and the 10 log 1, for example, tens, okay, or 1 over 10 is equal to the minus 10 dB. The law of tens is intuitive because multiplying or dividing by 10 adds or subtract 10 dB respectively, okay. Notice another handy rule of thumb. When absolute power values multiply, the dB value is positive and can be added. Okay, when the power values divide, the dB value is negative and can be subtracted. This table summarizes the useful dB comparison. Let me to verify it. About the when we have the 0 dB, okay, the power of 2 or 2 power are equal. When we have the positive 3 dB means the for example, our interest of power is 2 times of the reference power. Minus 3 means one half of the for example, reference power. The positive 10 or plus 10 dB means multiply 10. It means that, for example, P2 has 100 watt, and the reference has, for example, 10 watt, and minus 10 means 1/10 of the reference. Okay, try a few example problem to see whether you understand how to compare two power values using dB. Let me to show you some examples. In this figure, source A, B, and C transmit at 4, 8, and 16 milliwatt respectively. Source B is double the value of A, as you can see, okay? So it must be 3 dB greater than A, okay, as I mentioned before. And likewise, source C, okay, is double the value of B. So it must be 3 dB greater than B, as you can see here. Look at here, because here we have 2 absolute power, and the absolute power of B is 2 times of the absolute power of A. Because of that, we can say the dB of the B is 3, okay, 3 dB more than A, and also the dB power of C is 3 dB higher than the power of for example, B. Okay, you can also compare source A and C. To get from A to C, you have to double A, okay, double A, and after that, then double it again. Each time you double a value, just at 3 dB. Therefore, C is 3 dB, okay, plus 3 dB, or 6 dB greater than A. Let me to review. Source B is double the value of A, so it must be 3 dB greater than A. Likewise, source C is double the value of B, okay, so it must be 3 dB greater than B, as you can see here. And also, as you can see, okay, you can compare C and A here. To get from A to C, you have to double A and then double it again. 4 multiply 2 multiply 2, okay. Each time you double a value, just add 3 dB. Okay, therefore C is equal to 6 dB plus A. Actually, the C